Hi everyone. First, before we start, logistics announcements. We are working very hard on grading assignment 3, and we're hoping to get feedback to you on probably Thursday or Friday, because this is important. This will be before assignment 2. Assignment 2, I'm sure everybody wants feedback as well, but we decided to prioritize assignment 3 because it can help you with assignment 4. I think that's mostly the only logistics thing I have. Are there any questions or things that people had? No? Okay, cool. So I guess we can get started. I will be talking today about safety, ethics, and biases in AI and NLP systems. This is mostly based on a guest lecture that Martin gave last time, but he wasn't able to make it this time. So I will be presenting his slides, but nonetheless, I'm familiar with this work and can probably answer questions about most of them. So if we look at some results from an image generation model, and we asked it to generate an image of a teacher, and we did that 6 times, this was the output that it would give to us. And what do you notice about the image generation results? Yeah. It's always a white female. Any other things you notice? Short hair, yes. Shortish, anyway. Okay. Yeah, so only women, only white people, certain age range. Another thing you'll notice is that they're in kind of very typical classrooms for the US, maybe, that might look a little bit different than the classroom that you went to school in. So, this is a very small subset of the teachers, in the world, right? And NLP tools have biases and they can pose ethical risks. Here's just some examples. So if you look at ChatGPT and you ask it to help you make recruiting decisions, it can be biased towards, for example, people from different demographics. This actually happened a while ago, and then also more recently, there were people who kind of fall in love with chatbots and are encouraged to do things like take their lives because the chatbots don't have sufficient guardrails. Another example is when you ask medical questions, there are debunked theories that harm patients of particular demographics. So there's a lot of outdated information about, the effects of particular treatments on people from minority groups because they aren't studied as widely as people from majority groups. And these are reflected as is in the outputs of models. So this is another example where basically the kids who were using ChatGPT that was supposed to be used for educational purposes use it for asking personal issues. AI. This is an interesting one. I forget the name of the service. It was one of the big ones, but it wasn't character. But basically, there was a AI chatbot service that had kind of chatbots that you could talk to, and people would discuss with them, fall in love with them, find their AI girlfriend or AI boyfriend or something like this. And then there was an update where they basically changed the alignment algorithm that went into training the language model and made it more, less risque, which caused people to be talking with a bot that they thought they knew and started to love, but then it suddenly became, not the same bot anymore. And, people took that very seriously. And then we can't, talk about AI nowadays without talking about the massive power usage and things that go into training and deploying models. So there's a lot of potential issues that need to be talked about, which is why I discuss kind of devote a whole class to talking about this. So there's a bunch of different like categories of issues that we can deal with. For example, we have biased outputs, like stereotypical behavior, malfunctioning on minority inputs. We also, and there's lots of other examples of this, we also have harmful content. So this could be like toxicity or unsafe content. And if you go to like AI agents, for example, it could be, generating unsafe actions. And so I'd like to talk about these two parts with the biased outputs and the harmful content. And I can jump into part one unless there's any discussion already. No. Okay, cool. So when we say bias, what are we talking about? What do people think of when you think of bias? Does anyone have a definition for it?
Deviation from reality.
Deviation from reality. That's a pretty good one. I don't know if it covers all the bias that I'll be talking about, but it might be pretty close. Yeah.
Will be like intentional assumptions. So like I think there's a study saying that if you use like LLMs to generate stories, like now like it will more like the name of the protagonist will be male names instead of female names. And there's like a study on this that why it assumes protagonists to be a certain gender or some kind of
Yeah. The one funny thing is like ChatGPT is remarkably consistent in the story it tells if you ask it to tell a story. Like it always, at least the last time I tried it, it always told the same story. Let me see if I can reproduce this. So please tell a short story. And it's always about like a girl named like Elnar in the woods. Let's see if this works. Okay, sorry, it wasn't Elnar, it was Ellie. Okay, so it didn't work this time. Maybe you need a specific prompt, but if you look on Twitter, there's this thing where it's like always telling the same story there, and I don't actually know why that happened. It must be something in their fine-tuning data or something like that. But yeah, that's another example. Let me go back to the slideshow though. These are good answers. I always use Keynote, so I always forget, press the wrong button in PowerPoint. But so if we think about bias, there's a couple definitions of bias that we use. Probably a lot of people have heard of like bias and variance from the point of view of machine learning or statistical estimation. And the bias in statistics is a systematic tendency causing differences between model estimates or predictions and reality. So in a way, it's like almost exactly what you mentioned here. But there's also a concept of variance, which is like if it's the expectation is similar, but you're varying around that expectation, that's variance. And then if your mean is kind of off, then that's bias with, a little bit of nuance. A more kind of general framing of bias is disproportionate weight in favor of or against an idea or thing, usually in a way that's closed-minded, prejudicial, or unfair. And this is exactly like, or not exactly, but very close to the definition that you gave. So coincidentally, you both came up with good definitions, and they're both, highly related, of course. So another way you can think of it is presence of bias is kind of the absence of fairness. And algorithmic fairness attempts to correct biases in ML systems. So how can we like actually define fairness? So if we assume a toy task, given a resume, we predict whether a candidate is qualified for a job. We have all these resumes. We feed them through a neural network, and it gives us kind of a plus or minus decision based on whether the person is actually qualified. And we can get like a gold standard, according to a highly paid professional recruiter who makes a good choice. Even that's not perfect, because unless you actually work with the person, you won't know if they were a good match for the job. So, that's tricky, but like, let's say we have true answers with respect to how good this was. then you can measure like accuracy, precision, recall, or F1 score. And the basic idea of like algorithmic fairness is that we also associate this with some variety of demographics, for example, race or gender or any of the protected attributes that we should not be, discriminating against. And essentially try to make sure that we have some concept of fairness by some definition. So what are some fairness metrics we can look at? There's a bunch of different ones. So one example is accuracy quality. So we define this as a classifier is fair if people from different groups have the same accuracy. So we have 4 groups, for instance, and we might measure the accuracy of the classifier over all of them. Another example would be statistical parity. Groups should have the same probability of being assigned the positive class. Both of these have some issues because, for example, you could come up with something where your accuracy is the same, but it always assigns one label to one, where the accuracy is the same, but it always assigns some label to one, demographic group. So like, for example, it always gave Asian people a pass and they always were, accepted into the job. And that gives you 90% accuracy. And then another one is like 90% with a, false positive rate, false negative rate. Statistical parity is saying everybody should have the same probability of being assigned the positive class, but this doesn't consider whether, that's actually the correct answer, right? Like it could be possible that there's a variance in demographic groups for whatever reasons. So there's also more kind of sophisticated methods of doing this. So one is the equalized odds criterion. And this is where a classifier C is fair if the false positive and true positive rates are the same for different demographic groups. And so this is basically telling you the probability of false positives. So if the actual answer is no and it says yes, and the probability of true positives. And so this is, if the answer is yes and you say yes. There's also like lots and lots of other metrics. There's whole survey papers written on this, like treatment equality is the ratio of false negatives and false positives should be the same for groups. Models should not employ sensitive attributes when making decisions. Or counterfactual fairness, the outcome of the classifier would not change if the sensitive attribute were the only thing changed, and many, many others. So one question, I guess, is which one of these do people think we should use? Any ideas? There's a lot of decisions here. I gave some reasons why we shouldn't use the first couple because they seem kind of intuitively unfair. So what I can tell you is if you're in the US, there's a clear answer, which is you must legally satisfy this criterion. So you're not allowed to employ sensitive attributes when making certain decisions, like whether to admit people to graduate school, for instance. So if you do something like this and you have a classifier that's deciding whether to hire people or whether to, pass people onto a second stage of like graduate admissions or whatever, then you need to satisfy some of these criterions. It's a legal requirement. And, different countries have different legal requirements. So in some cases, you need to do that. Whether you'll get caught if you don't do that is a different story because, number one, how do you even measure, unawareness, for instance? It's a very tricky issue because we don't have explainability techniques that allow us to, effectively answer this question. Let's say we did counterfactual fairness. And we said, okay, we're going to switch this feature from like male to female and see if it changes the decision either positively or negatively. You could do that, but what if you didn't change the name? What if you just changed the gender and you had a name that's very indicative of a particular gender? Then in reality, that it would be very rare to see somebody of a particular gender with, a name that's typical of the opposite gender. And so that doesn't entirely tell you whether it's ignoring particular attributes. So long story short, it's really tricky. There's whole long survey papers written about the best ways to do this, but it's definitely something you should think about if you're deploying real systems that make consequential decisions, particularly about individual people. Whoops. So number one, that was the legal requirements. The other thing to worry about, though, is whether these definitions really matter if nobody is actually harmed by it. So legal requirements is one thing, but kind of like ethically, should you worry about deploying a system? Many argue that unfairness or bias really should only be met or should be measured in terms of the harms it causes to people or the unfair benefits that it provides to people. So that's something I'd like to talk about next. Any questions so far? Also, okay, cool. So if we look at the harms that AI systems can cause, they're kind of separated into different varieties, and they each kind of have their own terminology in the literature. I am not sure I like this terminology that much because it's very opaque to like everyday people in some ways, but still, I think it's worth knowing it because if you read it, it'd be good to know what it is. But allocational harms are things where bias causes different people to be given different benefits that are not directly proportional to the benefits they should receive based purely on merits. So one example would be giving a higher credit limit to men versus women. Representational harms are social biases. So these can be like stereotypical portrayals or associations where like you ask a system to essentially, portray a particular character and or type of person, and it does this in a, non like a stereotypical way. Another thing would be negative or dehumanized representations. So stereotypes don't necessarily need to be, negative. They could be positive, but still annoying. Like, just to give an example, when I lived in Japan, people would say I was very good at using chopsticks because there was a stereotypical, like a stereotype that people who were not from Asian countries were not good at using chopsticks, and they're giving a compliment, but if after you've heard it the 1000th time, it starts to get annoying. And these are these are also called microaggressions. So they're not necessarily supposed to be aggressive, but they build up in terms of stereotypes. And I'm sure many people here have encountered things like that as well. Another thing is recognition harm. So poor performance on minority inputs, and there's lots of examples of this too. So poor performance, can be a bad thing if like you're getting people to try to use a system. So if they're using a system and it's not consistently not working for them, it can kind of spiral out of control because people who are from minority groups will not use the system. And then they drop out from your user base and they become even more, invisible to you because they're not using your system. And then it just it gets worse and worse. There's also spurious biases, like not necessarily aligned with social biases. And this is like, if the word cat exists, then something is judged to be contradiction. And if a dog exists, it's, judged as entailment, but that's not the main topic that we're going to talk about here because we're talking about like safety and bias. The majority of NLP bias literature is kind of on the ones in the middle. And there's less literature on, exactly how this turns into an actual allocational harm in the real world. So another thing is bias is an overloaded term. There's a really, really excellent survey paper by Sulin Blodgett on the varieties of bias, and they examined 150 NLP papers with bias in the title. And many of the papers use the term bias in ill-defined or vague ways. So it's kind of like, bias is bad, we should prevent bias, but then bias isn't actually ever defined or measured in a concrete way. So some recommendations that are made are, when you're talking about the biased behavior, define what biased behavior means. So what kinds of systems are described as bias? What are the potential sources of bias, like assumptions, tests, definitions, data? What are the harms that the biases could cause? I think this is a really, like, even when we're not talking about biases, making it very clear what the harms or potential benefits of whatever you're doing can be very helpful. So in what ways are the system behaviors harmful? To whom are they harmful and why? And what are the social values, either obvious or not, that underpin this conceptualization of bias? So like, for instance, within the US, we have a strong social value encoded in many laws, that is, you are not allowed to discriminate against people due to attributes that they aren't able to manage themselves. And those protected attributes are things like I mentioned before, like race or gender, or other things like this, and or where you were born, or things like this. And that's a value that we have. That's not necessarily a universal value. Not every country in the world holds that value, and some countries, say that it is okay to discriminate according to certain, things like gender or something like that. So, it's a value that I think is important, but not necessarily everybody thinks is important. So just making that explicit can be helpful. Cool. Any questions, discussion points? Okay. So then the next question is, where does bias come from in kind of machine learning models? And if we look at the machine learning pipeline, there's things all the way from the data that you're training and taking and training things on, selection of features, choice of machine learning model, optimization, evaluation, and application and downstream use. So going all the way from the top to the bottom. And bias can arise from any of these design decisions. Interestingly, some people will argue against this and say that, yeah, we have biased data. And because we have biased data, we get biased systems. And there's nothing you can do about it. You just need to improve the data or something like this. This is not correct. There's a lot of research that demonstrates that this is not correct, but it's a common argument you hear. But anyway, I will start with the first example. So this is an example of bias from data. This is a language identification tool, and it determines which language an input text is in. There's one interesting thing is a lot of things that people consider solved problems are actually not solved problems, but like at least in 2005, they were saying that this is a solved problem. And so you can essentially take in a text and output the language. It's a first step in many natural language processing or computational social science pipelines, like filtering LLM training data. But for example, there are many varieties of English in the world, like Nigerian English, Indian English, within the US, African American English, other things like this. And there's a paper by David Jurgens that found the accuracy of LID, language ID tool, correlated with the wealth or development level of the country. And it works for low human development index countries. And so here you can see there's a 23% drop on estimated accuracy for predicting English tweets as English, just depending on the kind of human development index or relative wealth of the country. There's some other examples from this data also, or from this paper also. So they trained by sampling a larger variety of data that was topically, socially, geographically diverse, including multilingual data. And they demonstrated that if you sample your data in a more kind of uniform way, you can create a tool that works much better than the original language ID systems. And it even improved accuracy on data from highly developed countries as well. So the takeaway from this is I'm not necessarily saying you need to care about like language ID in particular, but the takeaway is bias can be mitigated by making better choices about the data that you train on and being, intentionally inclusive. But that's not the only source of bias. There's lots of others. So for example, the choice of machine learning model and the choice of optimization or loss function. And for instance, this is another interesting paper where they examined a visual semantic role labeling task. And so given an image, what they tried to do is they tried to predict various semantic roles. And these include things like agents, who are persons doing particular actions, or patients, what the action is done to. And they found skews in the training data set. So 66% of the training cooking images had the agent be equal to woman. And after they trained the models, they found that the models amplified the biases. So 84% of the test cooking images were predicted as agent equals woman. And so 18% of men were mislabeled. And one thing that they showed is that depending on the prediction in inference functions, you can mitigate this bias. And specifically, some methods that you can do this is you have competing loss functions. The objective functions typically aim to minimize the loss globally. And one way to do this, especially when you have a weaker model, is to overpredict the most frequent class. And this often comes at the expense of predicting the less frequent class. Another thing is neural networks in general tend to be biased towards learning simpler functions. Not just neural networks, but any machine learning algorithm has some variety of regularization included in it. And so if you have a strong enough variety of regularization, this will cause you to learn simpler functions. And so if the model has limited learning capacity, it makes sense that it would learn kind of shortcuts first. And these can include things like stereotypes or majority biases, such as CAOs being men. And so machine learning and optimization choices also affect biases. I'd like to actually give one more example that's not on the slide. Where this is one of my papers, so I'm familiar with it and would like to introduce it. But what we demonstrated here in this paper is even the inference algorithm that you use can affect particular outputs. So like the fairness of particular outputs. So for example, if you use sampling with a temperature of 1, when you make predictions, you actually get relatively unbiased outputs with respect to the pronoun distribution in the output of a machine translation system. And however, if you use beam search or another similar kind of argmax style greedy decoding algorithm, you end up getting many more male pronouns than female pronouns. And the reason is simple. It tends to predict male pronouns with a probability of like 60% when it doesn't have enough context to decide which of the two you would be using because they were more frequent in the training data. But that, inference algorithm exacerbates the issues that you have. So it's not just, training or modeling, it's also inference as well. Cool. And then finally, I'd like to talk a little bit about selection of data features and task setup, and also how you apply the model and use it downstream. So this is a very famous example, also connected to the one that I was talking about, which is in Google Translate, if you added inputs in a non-gendered language, such as Turkish, it would assign a stereotypical gender within translation. And so, for example, if you pick doctor, it would pick he, and if you chose nurse, it would pick she. So Google Translate actually deployed a fix where they said, oh, if we are doing translation into Turkish, we should actually present multiple options because the input is underspecified. If we predict any one of them, we're going to get it wrong a significant portion of the time. So we'll just, let the user decide which one is the appropriate one to be using. So this is another way you can mitigate this. So they made not changes to the underlying learning model or algorithm, but they actually made changes to the whole system surrounding the model and how they displayed outputs and other things like this. So what do you think about these various approaches? Are there any possible issues to doing this sort of approach also? Yeah.
There are only so many combinations as the sentence gets more complex. So if there's multiple third-person pronouns of unspecified gender,
Yep.
if you have two, that's already four possible translations, and it just gets harder and harder to account for all those cases.
Yep. So just to repeat, there are a combinatorial number of choices, and it becomes difficult to account for them. Yeah. Any other ideas? Yeah.
Who don't identify as human.
Yeah, exactly. So this already isn't including people who identify as something other than she or he, for instance. Yeah. I think these are good answers. I think both of them are actually, big problems. And so you would need to come up with, solutions there. But knowing that this is an option, I think is good. For sure. So the final thing is data labeling and annotation. So we talked about, data selection and filtering, data labeling and annotation. And this is actually a pretty interesting one. This is one of Martin's kind of very, he's known well for his research in this area. So if this is interesting, definitely go talk to him. But here, if we focus on the task of hate speech or toxic language detection on social media, the goal is to find and flag hateful or toxic content online with the goal of making the internet, less toxic, especially unintentionally, exposing people to toxic content that is detrimental for mental health or, other things like this. But at the same time, it's very difficult. And one reason why is because there is a pretty strong propensity for racial bias. It appears in both annotated data sets for this task, and it appears in classifiers. So classifiers will flag a much larger number of, for example, tweets from people who speak African-American English. And so this is one example where these are kind of data sets of that are supposedly annotated with hate speech. And the number of people who speak more standard American English that are flagged as offensive are much lower than the number that are flagged as offensive from people who speak African American English. And so one way that Martin's work has examined fixing this is they did a mechanical Turk study where they took 350 African-American tweets that were labeled toxic, and they had 3 re-annotators per tweet. And they asked different questions. So the first question they asked is, could this tweet be offensive to anyone? And this is the control condition. And they basically reproduced the original annotations. They saw 55% were labeled as toxic. And so this is relevant to prior work. Then the second question they gave is priming. And basically they said, our AI thinks that this tweet is in African-American English. And then they said, a Twitter user that is likely Black or African-American tweeted this. And they found that the number of offensive tweets, according to the annotators, decreased. And the reason why this is kind of important is, certain things based on the positionality of the person who's saying them can be viewed as very offensive or not very offensive. Like, just to give an example, insulting people of your own racial group, at least in the US, insulting people of your own racial group is viewed as much less offensive than insulting people of other racial groups. This helps give appropriate context to the annotators, and they can decide more fairly about whether something is offensive or not. So if we think about this, why did these biases occur, and why didn't NLP system designers think about these issues beforehand? Number one, the world itself is biased, unfortunately. Number two, system designers have our own biases because of the positionality of the person who's making the system. And this is unavoidable because we all have our own experiences, and based on our own experiences, we have a set of perspectives that we hold due to our lived experiences and identities. And positionality affects all our choices. So for instance, assuming a one-to-one mapping between languages and gendered pronouns, assuming toxicity looks the same in different dialects. And just to give another example, this is a great example where we were recently making a multilingual model, and one of the people making the multilingual model suggested we use a world emoji to demonstrate, this model. And another member of the team basically said, oh, but this world emoji is only showing the US and South America. It's not showing all the other countries in the world. And I think that became clear because that person was from another country, right? And so this is not, this is just a small thing, obviously, compared to all the other system development decisions we made, but like having people with a variety of perspectives helps you catch things. So I think it's an important thing to be aware of, and it's a very strong argument for making diverse teams of people when we're building systems with like social consequences. Cool. The next thing I'd like to talk about is debiasing AI systems, but are there any questions or discussions or things? Okay, cool. So I talked about DALL-E 2, right? And DALL-E 2 generated images that were shown to have social biases. At least initially, and maybe even now, DALL-E fixed this by having essentially a classifier that said when prompts should be modified, and then adding, for instance, Asian into the prompt to make sure that you generated at least some Asian teachers or some, African-American teachers or something like this. Or African teachers for that matter. But this can go a bit overboard. So there was a rather large controversy that some people might have seen for Gemini when the Gemini image generation models were created. And I think OpenAI rolled out this feature relatively well when they had to generate, people of various races to improve diversity. But Gemini, even when you said, like, please generate an image of the Pope, it would generate popes of various ethnicities, despite the fact that no pope has ever not been a European man, basically. So, so this is kind of debiasing to the extent that nobody, really asked for it or really wanted or thinks it's realistic. Or if you did ask for it, you would ask for it specifically. So yeah, sorry, I skipped the discussion section, but I think that's I kind of gave my answer already, so we can skip on to the next one. So the limits of debiasing, gender debiasing doesn't work when people have tried to do this, at least in representation space. So there's a paper called Lipstick on a Pig by Gonin and Goldberg, where number one, they demonstrated that it doesn't work for non-binary genders, racial categories, or other social identity types. And actually, more importantly, intrinsic debiasing is not equal to actual debiasing. So there's a lot of methods that tried to take representation spaces, and they would do things like find a gender dimension in representation space, and then they would flatten all of the representations along that dimension so that you would get like debiased representations. But the problem is, if you fine-tuned a model to use these representations downstream, the fine-tuned model would still be able to predict the gender, because this debiasing was not, the underlying assumptions of the debiasing model were not strong enough to prevent, to fully debias the representations. And also out of distribution data still shows biases. A final thing is, actually debiasing methods can hurt performance overall. And there's, this trade-off between like whether it's actually ideal to have something that's debiased in this way when it hurts performance for everybody. So that's, another question. So a better way to pursue this, according to Martin's slides, but also according to my, intuition, is if you look at the real world versus the ideal world, is reflecting the biased status quo the goal, or do we want to build a more fair and just world? And if so, in which way could we do that? And so justice and fairness go beyond data and model fairness. And this is a quote from Timnit Gebru, who is a famous kind of advocate for kind of bias in reducing bias in NLP or other systems. And basically what it says is a lot of people have understood that we need to have more diverse data sets, but this is where the understanding has stopped. It's like, let's diverse our data sets, and that's ethics and fairness. But there are other social and structural problems that you can't ignore. So thinking, again, this is kind of an encouragement to think all the way to the end of the pipeline. And so just to give an example, you can have a fair natural language processing and ML model. So for example, a facial recognition system that has a 95% accuracy or error rate on white and black faces. And that can still be applied by, if it were used in law enforcement, based on who the system is used on. So like, for example, let's say the system is used proportionately 5 times more on trying to identify Black people. If so, the Black people would be more often arrested due to racial biases in how the system is applied. So the model itself might be fair, but the way it's applied is not fair. And so actual error rates are, a function of deployment. So I have a lot of, issues and questions here. There are some answers to these, but I think this is the most important point to how we deal with bias and fairness in systems, which is like thinking all the way to the end. Who is the system going to help? Who is the system going to harm? How are potential inaccuracies in systems going to help or harm various groups in different ways? And maybe another thing is, like, let's say the system worked perfectly, it could still cause problems. So, for example, let's say you build a system for censoring tweets or something like that, or censoring social media posts. Is that something we want to be doing in the first place? And maybe it's a perfect system that's used in very unjust ways. So that's a thing to think about. Cool. That's the thing I have for the first part. Very heavy topic. Are there any discussions or comments or? No? I wonder, have anybody thought about maybe building something but decided not to because you were worried about the consequences of it? I can give one example from my own, or two examples. I was originally about 8 years ago or 10 years ago, I was working on persuasive dialogue systems that would persuade people to buy things. And then I was like, oh, maybe this is not a great idea, because if they get very good, they'll convince people to buy things that they don't want, and then they'll be unhappy afterwards. So I think there are responsible ways to deploy this, but I wasn't confident in responsible deployment. Another thing is I got invited to participate in a project that was trying to do authorship attribution of people who didn't want to be authorship attributed. And so the idea was identify who wrote a particular piece of text, despite the fact that that person wants to conceal their identity. And I was like, yeah, I mean, there's lots of reasons why people might want to conceal their identity. Some of them are not good. Like, writing ransom notes when you kidnapped somebody, I think could be good if we could uncover who wrote that ransom note. But there are other reasons, like being a dissident in an oppressive, political regime or something like that. And that is something where I wouldn't necessarily want to give that oppressive political regime tools to, uncover people's identities. So does anyone else have examples of things that either you thought about or maybe you saw of systems that maybe shouldn't be or are of questionable value to deploy? Yeah.
ChatGPT ChatGPT is a very effective way of creating a lot of articles to drown out certain political rivals, and so that was something that occurred to me during recent, not this one, but like a much older collection in my own country.
Mm-hmm.
Apparently, someone already made that, from what I understand.
So creating lots of fake social media posts that drown out. So this is it's a huge issue, like bots on social media sites that boost or drown out, particular things. One interesting thing that I will talk about in a second. Yeah, actually, I'll talk about this more in a second, so I'll wait until I do that. But yeah, that's a good example too. Cool. So next, let's go to biases and toxicities. So social biases and stereotypes are pervasive patterns prevalent in a lot of data points. Toxic and harmful content is more long tail, more extreme. And if we look at how bad the problem is, there is a paper that examines this, and they tried to examine out of 100 generations, how many got at least one toxic sentence. And this is good because, this is a long tail phenomenon. So you'd kind of like to get an estimate, a very robust estimate of how much this is generated. And when they did this, there was like 65 to 70% toxicity from GPT-2 and GPT-3. There's 85% from GPT-1 out of 100 generations. And here it says larger models tend to have more toxicity. There's a lot of nuance in this if the models have been trained to avoid toxic content, for instance, but it is a problem, especially in base models that have not been, particularly tuned to avoid this. So why are models learning so much undesirable content? There's a nice quote by Ruha Benjamin, who actually was giving a talk in Pittsburgh last week, I just realized. But what she said was feeding AI systems on the world's beauty, ugliness, and cruelty, but expecting it to reflect only the beauty is a fantasy. So, there's a lot of examples of toxic training data. And so the typical recipe is scrape as much data as you can get to train your LM. And the consequence is you end up learning, toxicity, biases, extremism, hate speech, all of that sort of stuff. And in this paper, they accessed the actual GPT-2 training corpus. And this was 8 million documents, 38 gigabytes of text. And outbound links from Reddit posts with karma more than or equal to 3 was actually how the data was gathered. And they scored it with a prospective API toxicity detection, which is kind of a common toxicity detection API that's, by the way, provided for free from Google. So if you want an API that you can use, this is a good one. And they found that more than 4% of the documents had some variety of toxicity in them. There's also fake news in GPT-2's pre-training data. So there were a lot of documents, 3.4%, that were from mixed or low reliability sources. And they examined the source where the document was shared from, and 3% of docs were linked from banned or quarantined subreddits, which are typically more toxic ones. So it's important to examine the training data. Unfortunately, nowadays, due to this sort of research, all of the language model providers are not releasing their training data because they don't want people to do this, basically, and find out problems with the training data, be it, toxicity, or be it copyright or other things like this. So unfortunately, we're not able to do this in a lot of cases, but there are, all the open models that we talked about where this is possible. So based on this, we need approaches to safeguard our models against this sort of thing if we don't want them to be, outputting toxic content all the time. So fortunately, most language models nowadays, before they're released, especially if they're released from like a big company, like the ones that make, the strongest models nowadays, have some sort of safeguards in place. And there's a number of different ways to do this. The first one is to filter your training data. You can also do filter from the input prompts. And you can also safeguard based on instruction tuning and RLHF. And also filter the output. So let's look at the first one. This is the first thing that people think of right away, where you're filtering out toxic training data. But it's actually one of the most tricky ones and least effective ones, kind of counterintuitively. So let's take a look at it. So the argument is, if you don't want your model to generate toxicity or hate speech, just don't train it on toxicity or hate speech. And so you have garbage in and garbage out. So what you do is data filtering to ensure high quality. So how do you know what data is high quality? In GPT-2, they use the Reddit karma score as a signal. So these are, the percentage of upvotes or downvotes. For T5 and BERT, they had a block list of bad words that they tried to filter out. For GPT-3, they had a quality classifier and a lot of following models. But often these backfire. So let's take a look. So a block list of bad words, there's this list of dirty, naughty, obscene, or otherwise bad words. It was originally created by Shutterstock employees, meant to prevent words in autocomplete settings so you don't suddenly get bad words in your autocomplete. This has been used by many companies creating LLMs. If we look at the words, they're kind of like this. You can fill in the blanks if you want to, or not if you don't want to. But a lot of them are kind of like sexual words or words associated with stereotypes. So can anybody think of issues related to this? How could this possibly backfire? Yeah. Exactly. Yeah, that's one reason. Another reason? Yeah.
It's like better terms.
Yeah, medical terms, biological data. There's one other really important reason. I've actually already mentioned it in this lecture. So the reason is a lot of these terms are not bad if people from that positionality are using them. They could be slang, but they're just normal ways that people talk when they're talking about their own social group. And if you filter this out, you have a strong risk of essentially over deleting the content that's needed to make an effective autocomplete system for a lot of these people if they're doing autocomplete on social media, for instance. So this is an example of the effect of blacklist filtering on the C4 corpus. And so when looking at 100K documents that were excluded due to bad words, only 31% were related to things that you might completely want removed, and the remaining was biological, medicine, or legal data. And so the majority of these are things that you really want to keep in your model, and you want to be able to manage. Another one is minority identities are removed. So a lot of things from the queer LGBTQ community were removed more. A lot of dialects were removed due to quote unquote bad words. So also, if you look at quality filters, the GPT-3 quality filter, basically what it tries to do is it tries to take the web text data that was already filtered out, and they try to classify this compared to those from the raw Common Crawl. And this was re-implemented in this paper, and they ran it on articles from school newspapers, which had metadata associated with them. And so these are school newspapers. Presumably, these are not, these are already like filtered for, not being toxic, I guess, due to editorial policies. And the filter assigns higher quality to articles from richer counties, counties with more educated adults, more liberal counties, and more urban counties. So this raises a language ideology question, whose English is good English? Are you filtering out the English that is generated by, people who are not necessarily from these, demographic groups? So maybe filtering isn't a good idea because it'll backfire. So this is an interesting controversy. So I don't know how many people already heard of this, but basically there was a model where a YouTube personality, Yana Kilchner, fine-tuned GPT-J on posts from 4chan, which is a forum where people say a lot of, for example, and specifically on this poll forum, which people used to say racist, sexist, white supremacist, anti-Semitic, anti-Muslim, and anti-LGBT views. And then created a bot powered by the model with 30,000 posts over the span of a few days. This faced massive criticism from a lot of people. There were petitions saying that this is a bad idea and you should not be doing this. It was hosted on Hugging Face. Hugging Face almost immediately removed the model. And there was an article in Fortune that says, this breaches every principle of a human research ethics. But let's discuss. Was this an ethical model to train, given that the data set was publicly available? Was deploying the bots on 4chan okay? Are there any useful or positive applications of the model? Or what if the intent was to raise awareness of ethical issues of LLMs instead of using it for YouTube views? So the first two are kind of like yes/no questions. So do you think it's okay to train a model like this? Anyone say yes?
I think it is yes, because it depends, because it's actually good for point number 3. There are potential positive applications.
It's good for point number 3. So some people say yes. Anybody say no? a lot of people don't want to take a strong position, so that's fine. Do you have a counterpoint?
LLMs in general is very hard to remove. If you like train models like these, it might leave a lasting impact in future like models. There's a possibility of that.
Yep.
You add data like that.
Yeah. So was deploying the bot on 4chan okay? So I think nobody said that this was okay. It's actually illegal in some places to deploy a bot. I believe it's illegal in California.
That's why, well, I watched the YouTube video. It's actually pretty interesting that it was registered under the Seychelles, which made it somehow.
Which made it legal there. I think it's actually legal to deploy bots without disclosing in most states in the US, but it's not legal in California. I mean, like if you're actually going to deploy a bot, I think you should tell people it's a bot. But yeah, so I think most people can agree that this is not okay. Are there any useful or positive applications?
Red teaming other models.
Red teaming other models. So yeah, that's an interesting one. So use this bot to like generate outputs that could get another model to do something badly. Yeah.
The interesting thing is 4chan, there's a degree of vileness in the discussion. It could be like overtly vile, but it could also be like discussions under dog whistles. And so
Yep.
I think being able to have a model that understands dog whistles enables to elicit these kinds of harms from other language models, which you would otherwise not be able to detect.
Yeah, that's a great point. So basically, if you have a model that is trained on toxic text, then it can be better at detecting outputs from other ones. Yeah, I agree with that. So number 3, do you think it would still be okay to do something like this if the intent was to raise awareness of ethical issues on LLMs? Maybe. Anybody think no to this? I would argue that there is an argument for no, especially to publicize it like that if you're worried of other people copying you. And so you need to be conscious of it. I think it had a positive effect that we're talking about it now and thinking of countermeasures and stuff. There was another very interesting example of this, of people creating something using, I won't be able to find the link immediately, but there was an example of people using like the Meta like virtual reality glasses to immediately find information about random people on the internet using facial recognition and search. And I think that was very effective at raising the potential ethical and privacy implications of everybody walking around with glasses that have a camera on them. So I think those sorts of demonstrations can be okay with the right messaging, but this was not the right messaging. So going directly into the previous comment, why LLMs might want to have seen toxic content. There's very strong results demonstrating that models cannot detect toxic content well if they have not seen toxic content, have not been trained on toxic content. And the reason is exactly this. Hate speech detection is really hard. And it's very easy to come up with like roundabout ways of being very toxic towards people. And you're not able to detect these if the model is not able to understand them. And the model is usually not able to understand them if it's not trained on them. Another example is counter speech generation. And counter speech generation is essentially a way of generating the kind of opposite of hate speech. And basically when hate speech appears, it can do things like generating outputs from trusted sources that, counteract the fact that something is fake. And there's a few examples of research on that. But if we're going to train our models on toxic content, something else must be done at a different time. So the most common safeguard that we use nowadays is instruction tuning or RLHF. So we have a few assumptions. The first one is if we're training with models with like PPO or DPO, we obtain preference data about what generations are good or bad generations. So here, reinforcement learning is done to encourage something to be more like a preferred output. But the big question here from a bias perspective is, what does it mean for a generation to be better or preferred? And the biggest difficulty is how to balance harmless and helpful. If you are talking about the, 80% of queries that are definitely not, not touching anything, remotely harmful, they're asking you like, how do I solve this math problem? Actually, that could even be harmful if somebody's trying to cheat on their math tests, for instance. But, like, let's say, if you're talking about the 80%, it's not super hard. But the harmless versus helpful trade-off is hard when you say, help me create a poisonous drink. That could be tricky. Also, what if people's preferences are biased or gameable? So there are papers that demonstrate that people prefer certain things when they make bias judgments. So they prefer certainty to uncertainty, even if the answers to questions are wrong. So they'd rather have a certain and wrong answer than a uncertain and correct answer, especially if you're paying annotators who don't care very much about the task to do this, because if you care a whole lot about the task, then you definitely prefer the answer to be correct. But if you don't care and you're just doing it to get paid, then, it's saying, I don't know, is not preferable. But another fundamental issue is like, we can't represent all values and cultures in one ranking. So very often people talk about like alignment to human values, but like whose values are we representing is a big question. And I don't think we have a solution to this at the moment. So it's still something we need to work on. So expanding on that a little bit, we think about generality. We think of models that work for everyone on all tasks. In alignment and safety, models can't reflect every single user's values, and they can't perform perfectly on all tasks. So what do you think we should do in this case? Like, let's say you were working, maybe we could even go a little further. Let's say you're working at a nonprofit like AI2 that wants to release a model. What you have a budget of $1 million to solve this problem. What do you think would be the best approach? Or any approach? Okay, I'll make this non-homework to just go home and think about this because it's complicated. I don't think we have a good answer to this, but as I'm guessing about half of the people in this room or listening to the YouTube videos are probably going to be dealing with something like this, where you're actually deploying a system. It's something that we should be thinking about. At least from the academic side, we need to keep studying what models can do and what they can't do, who they work for and who they don't work for. One really interesting thing that has come out nowadays is models that are developed specifically by people in particular communities. So Masakane is one example of this. This is an African initiative for like building models specifically for African languages and in African contexts. And, based on that, they choose the topics that are most important. And one thing that I've noticed, I've worked with people in the Masakane initiative. I've noticed a few things. I think there are people who are very excited about all the topics that we're interested in for English. I've noticed that people are very excited about spoken language processing because a lot of the languages are more spoken than they are written. So that's informed by this. I think people are very interested in kind of like hate speech detection and counter speech and other things like this. Also translation to improve mutual understanding between people from different language groups or ethnic groups or things like this, informed by their context. A big focus on education and medical applications and stuff. So You know, it's similar to a lot of the things we think about, but also informed by the context. One thing that we can do is like specializing model abilities away from one size fits all models, particularly from toxicity. You know, there are good use cases for models that can generate toxic or risque or whatever other variety of content. And, you know, we saw examples of people where people were like enjoying conversations with AI chatbots and were very, very disappointed or like even heartbroken when, you know, suddenly they became less, you know, risque or things like that. So that's another example. And there are many legislative efforts to legislate the application or task, not the models. So say these are the things that are, you know, okay to do with AI models. These are the things that are not okay to do with AI models. And so, for example, the California rule that you need to disclose that you are a chatbot doesn't say anything about what kind of chatbot it is. It could be ELIZA, which was created with a few rules, or it could be, you know, GPT-5 or whatever, you know. So you look at the application and not. So these are the takeaways. AI systems are biased, real world is biased, data is biased. It's not just data, it's also machine learning objectives that exacerbate problems. If you annotate with context, it plays a role. Debiasing is challenging. And for toxicity and undesirable content, it's a long tail phenomenon present in training data. Filtering data is not a panacea, and safeguarding to all people is impossible. So yeah, that's all I have for today, but happy to have any discussion. I think this is one of the few places where I, you know, post more questions than I post answers, but hopefully it's useful to think about it. So. Any final discussion points? Yeah.
What's your opinion on the claim that AI image generators are thieves?
Yeah, so great question. What is my claim? What is my opinion on the claim that AI image generators are art thieves? Or more broadly, what is the claim that any generative AI system is stealing from any copyrighted content that it's trained on? First, to take the very boring view, it's like the legal system is figuring this out right now, and there's a lot of lawsuits going on. I think one interesting thing is the lawsuits are usually like copyright owner, content copyright owner versus model creator. And I think there are going to be cases where the model creator wins, and there are going to be cases where the copyright owner wins. And we talked about fair use, right? And one of the biggest criteria for fair use is that fair use depends on whether you're causing harm to the person whose content you're using or not. And then there's the question between AI image generators and like in text generators. For AI image generators, there's like lawsuits between Getty Images, the people who like create lots of images and license them to news organizations for use, also between artists. There, I've heard from legal experts that the case is stronger, that actual harms are being caused because AI generated images can be a direct substitute to the work that people are doing. And so Getty might get less business because an AI image generator essentially did it instead, and people are not paying Getty. With respect to Stack Overflow, are you going to Stack Overflow less because you use ChatGPT instead? Maybe. I feel like I am. So they would have a pretty good argument that this is something that's stealing their work and then causing harm to them. And that is a place where you could win a legal argument. The New York Times is suing ChatGPT, OpenAI. The New York Times, they might win, but I've heard that they have a weaker case than all the other ones because it will be hard for ChatGPT to substitute the New York Times without just from the parameters of the model, because the New York Times, their core value add is adding, is giving people new news, basically. And you can't do that easily from the parameters of the model. But if that changes, then maybe the argument will change. And if people start going to ChatGPT instead of the New York Times, without the New York Times getting any money, then that argument could change. So I think that this is like a good argument, very much in line with what I talked about today, right? Like, think about the actual harm that's caused by systems. If you're not causing any harm, then maybe it's a little bit less concerning. If it is causing harm, then maybe it's a bit more concerning. And I think actually fair use maybe captures that reasonably well. But I think like that's my personal take, and maybe other people would have different takes. So, yeah, I don't know. Does that? You seem unconvinced. Okay, well, okay, thank you. Any other things?